Okay. So this is one of the most important videos. I mean, why this is one of the most important videos? Because this is going to question our main philosophy on how to think, where to invest our capital and where to invest our time in, right? I mean, these are the two fundamental decisions as human beings we keep on making. Where should we invest our time and where should we invest our capital in order to get some positive returns? And for smarter people, they don't only aim for positive returns, they aim for positive asymmetric returns, right? So they invest X amount of time and they get 10x of returns, right? So AI is one of that particular bet for a lot of engineers and a lot of companies, right? So it is one of the most practical skill for the 21st century, right? So most people learn AI for the most boring reason, right? And when I say AI, I'm thinking everything under the umbrella: machine learning, deep learning, generative AI, modern AI, then obviously your tools, adoption, strategy, everything, right? So a lot of people, and especially the people who belong to the engineering track, they think about AI that this is going to help us get employment, right? They treat it like a software update for their CV. So it's true that learning AI will give you employment. I mean, will make you employable and will, give you that employment. But treating it like a simple career hack, maybe like you do DSA, like you do low-level system design, that is a tragic waste of potential of AI, right? It's like you are learning to fly a jet just to avoid the traffic on the M25, right? So you don't want that. So we believe that you should learn AI for far more interesting reasons because it changes the way you view the world, right? So you get multidisciplinary learning, right? So especially when you're learning AI as an engineer or even as a non-engineer, you're trying to dig deep down the algorithms. You're trying to study the older classical machine learning algorithms that were, the OG algorithms that gave rise to the neural networks. So you definitely naturally get multidisciplinary. Now, how? So you get to fiddle with probability, you get to fiddle with statistics, you get to understand calculus, the optimization theory, and linear algebra, like how all of these equations with so many variables are being treated as matrices, and then we are parallelizing their computation using a GPU. So this is basically multidisciplinary learning. Coding is the most easiest part, right? Especially when you are trying to dig deep down an algorithm. So if you're using certain library functions, then coding is one of the most trickiest part. But especially when you are trying to understand an algorithm, you definitely get multidisciplinary flavor of mathematics and of computer science, and you realize that these small function approximators, when fed large amount of data, behave you know s- behave in such a great way, right? I mean, they become so useful. These simple mathematical equations, they become so useful when they are fed with large amount of data, and you would understand how scaling comes into picture. And obviously it expands the horizon of your brain, right? You learn to think about systems in a different way. Now the second reason is that since you are exposed to an AI algorithm, you would automatically be building an AI system, whether it is a small scale system or a large scale system. So you would get an opportunity to demystify AI and you not treat it as a black box. Now, neural networks are not a black box for you. Convolutional neural networks are not a black box. You understand how an AI system treats multi-model data. You first understand that we had domain specialized, modality specialized networks. Now we have multi-model networks that can treat multiple modalities all at once. We have vision transformers, we have text-based transformers, right? So you would demystify everything under a black box and enhance your idea of first principles thinking. You would polish the way your brain invokes the system to thinking and the first principles thinking, especially around these algorithms and the fundamental principles. So you would be able to understand that okay, this AI system is having these certain high level components that are stitched together to perform in a certain way, whether it is autonomous or with a human in loop. But it's definitely going to give you a great sense of first principles thinking. Now, since there are so many ambiguities and unknowns in any AI system and then an AI algorithm, you would get the art of navigating that chaos. You would understand the art of navigating through complexities, navigating through unknowns, navigating through uncertainties. So engineering is all about that. Engineering is not about coming up with the best solution in the first go. Engineering is about even thinking about the brute force approach. then thinking about optimizing it, then first doing the feasibility check whether whether the problem that we're trying to solve is even feasible or not. And how do we understand when the problem is so naive, when the problem is so ambiguous, when the problem has so many uncertainties? How do we break it down into a problem, in and reduce its degree of certainty? How do we break it down into a problem or into set of sub problems that can be solved, right? So the first thing was multidisciplinary. Second thing is you demystify the whole AI ecosystem as a black box, and you don't treat neural networks as black box. Then you understand how to navigate chaos. You hone that ability of navigating chaos. Obviously you already have that problem solving ability of navigating chaos, but when you learn hard concepts like AI and machine learning and deep learning and generative AI, and you try to build things from scratch, especially these AI algorithms, you will be able to understand how to navigate this chaos, how to navigate uncertainty, how to navigate ambiguity in any larger problem, and how to break it down into sub problems such that it is solvable. And you know it becomes modular, and you can solve it in a batch, and you can solve it in a serial fashion in order to conquer the whole objective of the problem, right? Then I think this is also very important. So now the fourth reason that you should learn AI beyond a job is you would get a fair sense of judgment and opinion on what's happening in and around the AI world, right? So you would know where to invest your time and where to invest your capital. Let's say if you're investing in hot tech AI companies, you would get to know which company is definitely a hyped company and which company is trying to do the work and has a business moat and has competitive advantage and is going to stay deep into the system. You will become so opinionated. Now, once you understand AI and all of its algorithms and a lot of subcomponents and what's happening in and around the world, you're keeping up with the AI. You will be able to keep up with the AI research. You will be able to keep up with the AI news, any new models and any new algorithms that are coming up. You will know what is it going to change and how it's going to impact. Otherwise, you would just treat it as a passive story that is playing in the background, and you are just witnessing what is being played. So once you learn everything around AI, or once you get comfortable with the whole AI ecosystem, you will become so opinionated and you will have a stronger judgment around what's coming. If a company is coming up with a new model and they say that, we have broken down a trillion parameter model to a billion parameter model and even 1 billion parameter model. I mean, we are saving so much of compute, so much of cost, and we are still able to beat the performance. So why does small models perform better? You would get to understand, right? Because you know the idea of parameters, you know the idea of modalities. Then if there are news that there are 100% autonomous agents that are building XYZ, that are building cryptocurrency, and they're mining on their own, that are building trading algorithms and they're trading on their own, you would know that there's a lot of hype, and there's a lot of misalignment and a lot of noise in these kind of news, right? So having a fair sense of judgment and opinion in your particular field gives you a certain edge and helps you take bets that are dramatically useful in the future. If you will be able to take a bet on a company that that you believe in is going to 100x 1000x in the future, so that if you go do a job in that company, you know that your ESOPs is also going to explode and give you that disproportionate edge. So the learning AI will also make you opinionated, and you can use those particular opinions to figure out what is noise and what is signal, and which signal is worth acting on, which company is worth investing on, what kind of models, and what kind of research areas I should look upon. Right, there's a lot of work that is going on in continual learning, so that we need to achieve AGI using continual learning, or continual learning is going to be one of the component in AGI. You would get this sense of opinion, and you would not fall prey to stupid news around AI. People say that my AI makes billions of dollars for me while I am sleeping. So there's a lot of fake news that goes around AI. You'll be able to you know get rid of that with your fair sense of judgment. And all of these companies, especially the frontier AI labs who are chasing AGI, you will be able to understand the whole research. Now, if you are already a software engineer, it's like it's going to give you more gears in your car, right? You already understand backend, front end, distributed systems. You already understand fair bit of engineering. You are familiar with low level design and high level design. It's a very good time to dive deep into these AI algorithms and the AI systems, and maybe code them from scratch, or you first use them as libraries and then code them from scratch and think about how the training is done and what exactly is going on with all of these algorithms. So it's going to give you a certain edge that you cannot imagine. It's going to expand the horizon of your thinking in engineering, and it's also going to make you multidisciplinary. So if you are an engineer, I think then though it's very much useful to take a bet on learning AI and navigating all the algorithms under the hood of deep learning and machine learning and generative AI. Yeah. Even if you're a non-engineer, if you belong to a track that is a leadership track, you will be able to actively and proactively suggest meaningful solutions and suggestions if you understand how to evaluate any problem with an AI lens, right? So because as a leader, it's very important to be a constant mentor for your team. And if you want to stay a relevant technical leader, whether you are a program leader, product leader, engineering leader in any organization, a services organization, a product organization, or an investment bank, or a retail bank, then also it's going to give you a massive edge, especially the AI applications and AI strategy and AI adoption part, right? And if you are a little mathematical and if you want to get your hands dirty in code and math, then it's also going to enable you to sit in those technical discussions with your engineering team and maybe suggest them meaningful solutions, read through their solutions, and understand how these AI systems are built in the world. Yeah, I hope it was useful, and I hope each one of us gets to explore and learn more and more algorithms and more, systems in the umbrella of AI and leverage them for our future in multiple disciplines of our life. Thank you.